Again, my encouragement is when on a competitive exam is to read all the questions first. And I'm just doing one at a time, by the way, but I don't think I would take this one first. If I were looking at problems in this thing, I'd probably be looking at 4 first and then go to 2, blah, blah, blah. All right? But all right, let's attack 1. I go to the whiteboard to do it. It looks like a tough question to me. All right? And one is to understand what they're asking for. So what are they asking for? Again, problem number 1. I'm hearing that they have a circle that has a radius r and centered at 0r. So I'm going to draw like what I call a really bad picture. All right. So let's put this over here. It's got the centers here. That's going to be 0, comma r, and it's a radius of r. So it looks. And again, I know my circles don't look so great, but I'm going to say that's my circle. All right. Then they go on to say over here. It says, write an equation for the locus of centers of circles which are tangent to both circle O, that's the big circle, and the x-axis. So if I were looking at this, I'd probably, try to draw that, and I'll draw that in the best of my ability. That there's going to be a circle drawn over here, and it's tangent to this over here, and also to the x-axis. And I'll be honest with you, that's it. My pictures are awful; they really are. But anyway, I'm going to do this over here. There's a center there, all right. And I'm kind of looking at this. And let's take a look and see what we come up with over here. All right, so I got I say like a pretty, not a very good picture, by the way. But anyway, I have to read it again. It's a circle, a big circle. I got that. And then it says radius r. I got that. Centered 0r. Write an equation for the locus of centers of the circle. So really what I'm doing is I got to get the centers going. All right, so I'm looking at the centers. And there's going to be a bunch of circles, by the way. All right. And, what kind of curve is this? I'll get to that later. So I'm going to take a point on the circle. Let me make this over here. And the point's going to be x, y, right? And then I'm going to write down an equation for that, all right? But I got to really start thinking about it. Let the, you know what? I'm going to switch shifts in this one because I don't want that point, all right? So let me go backwards. So this is what you don't want that point. Really the point I want is this point over here. I'm going to call that xy. All right? I'm going to call that xy. That someone says, what is that? I'm going to point out that I don't even know the radius of the circle, but it's always changing, by the way. All right? So it's always going to change. All right? So I'm going to say, there's another circle there. Its center is going to be xy. And what I'm going to do is put down, what I got to start thinking about that now. So let's take a careful look at that. All right. So the other circle centered at xy. The big circle I see right over there centered at 0r. I'm going to be careful now about this, where that center is. I got to start thinking that. I'm going to draw another line over here. And I want to start thinking about that now. And I'm starting to see something over here, that this point over here is just the x-coordinate, and that will change, by the way, and the y-coordinate there is 0. So I get this over here. And what's this over here? This is just going to be the y value, and that does change also. All right? And I got to look at that, and I got to start thinking about things now. This xy is killing me at this point. And I'm going to say something about the Pythagorean theorem. Put a little right triangle there for you. And I'm going to try to see if I come up with something there. And looking at it, I got this dimension over here. I look at that. And what do I get there? Let's write this down. That's going to be r minus y squared plus, well, let me get this dimension over here. I get one step at a time, by the way. And what's that going to be? Well, looking at my picture, just x. That's going to be x squared equals, wow, I got to do this now, don't I? That's the hypotenuse, isn't it? And the hypotenuse, I got to look at that. And I got to be careful here. Oh, I think I see it. I'll tell you why. The radius of this thing, I know the radius of that. And what's the radius of this thing? The radius is just a coordinate y. That's what the radius is. So what would the length of the hypotenuse be then? Well, I'm looking at it. This is r, and that's going to be just the y. All right, so I can write that down now. That's a nice relationship to know, by the way. And what's that going to be? That's going to be r plus the y, and this Pythagorean theorem squared. All right, what I want to do is, multiply it out now. But I want to go back and read the question, see if I've done what they wanted me to do. Circle, big circle, radius r, centered at 0. I got that. Write an equation for the locus of the centers of a circles, which are tangent to both that big circle and the x-axis. And I drew a picture of it. Not a great picture, by the way. All right, I'll do that. I got the equation, by the way, so this is good. But they're asking me what that is. Let me write this over here. So r squared minus, let's see, it's going to be minus ry minus 2ry plus y squared plus x squared is equal to r squared plus 2ry plus y squared. Well, I'm looking at this thing over here. I'm not going to say it's obvious what it is, but I'm going to subtract r squared from both sides. That disappears. I'm going to, subtract y squared from both sides. They disappear. And then I'm going to say x squared. Right, I see that on the left side, by the way. And I'm going to add this to both sides. And what would you get? You get 4ry. And what do I notice about this guy over here? It's a parabola. And we're done with question number 1. So question number 1, I found the relationship of those points x, y, and those relationships turn out to be a parabola. So if you were to graph that out, you'd see a parabolic function. Thank you.